So go ahead and take a second and write these properties down. The product property means if you have two things being multiplied inside of a logarithm, they can be separated into two separate logs with addition between the two. And it goes both ways. So if you have two logs being added together, you can combine them to one log and multiply what's inside of each of those logs. Now, for all of these rules to work, the bases have to be the same, and the base stays the same all the way through. So when they're multiplying, you separate them into two separate logs with addition. When two are being divided inside of a log, you can separate them into two separate logs using subtraction. And when you have a power inside of a log, meaning a number being raised to an exponent, you can move that exponent out in front and it's being multiplied with that log there. This term basically means if you can get what's inside the log to have the same base as the log and these bases to be the same, then this whole thing, the whole log, is equal to whatever this exponent is. And that's what these first few are doing. And basically what we just did in the previous assignment, evaluating logs, that's basically what you're doing here. You're doing a slightly different way. I would need to get this 125 to be a base of 5. So this would become log base 5 of 5 to the third. And because 125 is 5 to the third, this is still equivalent. And because these two bases are the same, that whole thing is equal to 3. And if you evaluate this like we did before, you would also get this to equal 3. Here is straight up the rule. These two bases are the same, so this whole thing is equal to 6. Go ahead and try this one on your own. I'll use this as a you try. Here comes the answer. And you would get log base 4 of 64 is equal to log base 4 of 4 to the third. The bases are the same now, so the whole log is equal to 3. You're going to have to try and notice when that is going to apply. If you ever can get the base of what's inside the log to be the same base as the log, do so and simplify it using this rule. Okay, so one more rule is that if you ever get a log, doesn't matter the base, if you ever get the log of 1, it's always going to equal 0. It doesn't matter what the base is, because if you understand the logs, you're saying this base raised to what power is equal to 1. And anything raised to 0 is equal to 1. So even if it's log base 500 of 1, because 1 is inside the log, that's always going to be 0. Write this rule down as well. It's just one that I forgot to put originally. So we're going to be looking at the product property here and the quotient property. Now, you've already written these rules. You don't need to necessarily write them again. I just wanted them on this page as well. These I'm going to write, the directions would be write as a single log, and this direction is going to be to expand the log into several different logs, more than 2. Let me go ahead and change colors here. So they're both base 3, log base 3 of 7 plus log base 3 of 4. What I'm going to do with the two numbers that are inside the log, I'm going to bring it to one single log and multiply those. So it's going to be log base 3 of 28. And that's simplifying it into a single log. Where this one, I have I have log base 3 plus I have log base 2 of 3 plus log base 2 of x minus 2. So when I bring them together, I'm going to be multiplying that 3 times x minus 2. And all of that is inside the logarithm. So it's going to end up simplifying to log base 2 of 3x minus 6. Now I do need to keep that in the parentheses to express that the whole thing is inside the parentheses. If I just write it like this, what this expresses is just the 3x is inside the parentheses and the minus 6 is on the outside. So if you want the whole thing in it, you got to express that using the parentheses. And here to expand it. So I'm basically using this rule, and you have to notice, well, what's being multiplied to get to 15? So that's going to be 5 times 3. So I can expand it into several different logs using the rule log base 5 of 5 plus log base 5 of 3. And then notice these bases are the same, so this whole log is going to equal the exponent. Well, the exponent's here, it's not shown, but it really is a 1. So that's going to be 1 plus log base 5 of 3. The quotient property, I'm going to expand this one, and I'm going to condense these. Condense the logarithms means that you're writing it as a single log like we did with number 4 and 5 here. So to expand this one into several different logs, they're being divided, so I'm going to write them as 2 separate logs using the rule, and I'm going to subtract the 2 separate logs there. And that's it. That's as much as I can do there. So to expand this one, so to condense this one, I'm going to have a log of 12 divided by 3, and because I can simplify that, go ahead and simplify that, and that's going to become log of 4. I can't simplify that because the base is not 4. We'll talk about what this base is in the next unit. But if it doesn't show a base, you don't need to write the base. And for this one, I have log base 4 of x plus 4 divided by 6. Because they're being subtracted, I'm going to divide each of them, and all of that is inside a log, so I'm going to put it all in parentheses, and that's it. I can't simplify that or do anything else to that, so that's all there is. And the power property. And this could go either way. When I have this number out in front being multiplied with the log, you can write that as the exponent of what's inside the log. So I can write this as log base 5 of x raised to the third is going to be the same as 3 times log base 5 of x. So when I have log of y raised to the fourth, this exponent can move to the front and be multiplied with that log. So it's 4 times log of y would be the same as that. And that's basically it, going one way and from one way to the other and back. These next few have several different rules embedded in the one problem. So this is going to be to expand. You may end up making mistakes if you try to do too much at once. If you take it one step at a time, I'm going to separate these with the division part first. Because x, y is being divided with 5, I can separate each of those into 2 separate logs using subtraction. And then now I have both this x times y inside of this log, so I can separate that into log of x plus log of y, and they're base 5, and if you notice here, log base 5 of 5 is going to equal 1. Because the bases are the same, this exponent is 1, so it's just minus 1. And don't put this in parentheses. This is not inside the log. I only want that y inside that log there. So this is the expanded form of number 12. And to condense this one, before I multiply, because this is being added, I'm going to multiply what's inside the logs. But before I multiply this x and y, I have to take care of that coefficient to the log, which is going to become the exponent. So this becomes log of x raised to the sixth plus log of
Janine Torres, please come to guidance. Janine Torres, please come to guidance.
log of y raised to the fifth. And now I can combine them into one log of x to the sixth times y to the fifth. And now it's written as a single log there. So go ahead and try to do these two, 14 and 15. 14 should have come out to 3 log base 9 of x minus 2. When you separated them, use the minus because they're being divided, and then this 3 comes out in front, and this 81 can turn into 9 squared, and now these bases are the same, so the whole log becomes 2. Understand that it's just this x inside the log though. And then this one. This is one that a lot of people will get wrong. Do it one step at a time, and you get the exponents on the y and the z, and then just do these two logs, and it becomes log of x over y to the fourth plus log z to the third. And then when I multiply those, I'm multiplying, and this z to the third is really z over 1. And when I multiply it straight across, it should be multiplied with the numerator here, which makes it x z to the third over y to the fourth inside the log. Basically, what it's going to mean is if the log has a negative or a minus in front of it, it's going to be in the denominator. If it has a plus or a positive in front of it, it's going to end up in the numerator. So this says use log base 5 of 2 as approximately 0.4307 to approximate the value of log base 5 of 250. So you have two things you have to pay attention to. They're giving you the value of this log, and it has a base of 5. So if you can get anything else, any other log, so start out trying to separate this so you have a log base 5 of 2. So if I can get 250 as written as 2 times 125, I can separate these into two separate logs. Log base 5 of 2 plus log base 5 of 125. And then now if you notice, this log base 5 of 125 is going to become log base 5 of 5 raised to the third. 125 is 5 raised to the third. So you know the value of log base 5 of 2, which is 0.4307 plus, and this, you can use your rule, the bases are the same, the whole thing is equal to 3, and when you add those together you get 3.4307. Yay! And we can do the same thing here. I have log base 5 of 6, log base 5 of 216. I know log base 5 of 6. So what I can do, if you notice, 216 becomes 6 raised to the third. So what I want you to try to do for one like this is notice that it's an exponent, and now use your power property, which is going to move that 3 out in front, and I have 3 times log base 5 of 6. Well, I know log base 5 of 6 is 1.1133. And so when I multiply that, I have 3.3399. Yay! Okay, so go ahead and try these 3, and I'll give the answers in 5 seconds. Okay, so you should have gotten for the first one 6.5850, the second one 5.17. This first one, going back to show you how I did it, if you can see here, I wanted to get a 3 out of this 96. So that 96 is 3 times 32. And if I separate those, I know what log base 2 of 3 is from what they gave me.